video we are going to discuss about the arithmetic building blocks. On completion of this arithmetic building blocks, students will be able to find out the methods that are used for optimizing the adders. They know the worst case delay of the ripple carry adder. So in this this is the major generic digital processor. Here we have the inputs, memory, control and the output. The major building blocks of the architectures consist of the bit sliced path, that is adder, multiplier, shifter, comparator, etc. So these adder, multiplier, shifter, comparator are placed in a sliced data path. It is first it contains adder, next multiplier, next shifter, next comparator, and it also has a memory, that is ram, rom and buffers, and also it has a shift registers. The control which is used here is finite state machine and the counters, and the interconnect which are used here is the switches, arbiters and bus. And in the bit sliced design, this adders, multipliers and shifters are used in the data paths of microprocessor and signal processor. So the data path is the core of the processor where all the computations is performed. In this blocks, it supports the units for storing the results produced by the data path, or it helps to determine which will happen in the next cycle. And this data path is nothing but the interconnection of basic combinational function such as arithmetic operations such as addition, multiplication, comparison, uh, and shifting, or logic functions like and, or, and XOR. Mainly this depends on the application sets. And here this bit sliced data paths contains the register, adder, shifter, multiplier. This information is transmitted in a bit slice path, and the information is collected in the bit 0, 1, 2 and 3. Finally it is transmitted to the output. And here we are going to see about the adders. So this adders is nothing but it is mostly used in the arithmetic operation, and it is often the speed limiting element as well. As also this careful optimization of this adder is mainly important. It is done in the logic or circuit level. It contains two types of optimization. One is logic level optimization and circuit level optimization. So here it carries the status of delete, propagate and generate. If it is generate, it is equal to the multiplication of the product inputs, that is a and b. Propagate is a exclusive b, delete is a bar and b bar. This ripple carry adder which is used in this adder is expressing the carry inputs, and it is generated when g is equal to 1, a carry bit will be generated, and when g is equal to 0 it is deleted. And in the case of the ripple carry adder, this delay is proportional to the number of bits in the input words n, and it is approximately used, so we call it as t adder is equal to n minus 1 t carry plus t sum. The propagation delay of this ripple carry adder is linearly proportional to the n. So this property is used in designing the adders of wide data path. So here you can say that if a is equal to 0 to 1, then b equal to 1 1 1. This fixes to a worst case delay condition. So for designing the full adder, this ripple carry adder is important to optimize it. Quiz questions on arithmetic building blocks. Give the propagation delay of n bit ripple carry adder. Thank you.